Okay. So I guess we can get going here. This is just a tutorial about how to use Celery somewhat effectively. So I think that there's a lot of tutorials out there on how to use Celery, and I found that a lot of them didn't show working code, which is difficult for me because working code, there's just small details that make everything go wrong. So I wanted to post some working code so you guys could go to it and work on it if you wanted to do Celery in the future. So if you want to follow along, you just clone this repo, and I will show you that the directions have changed somewhat for how to get it up and running, which is you need to first of all install all your apt-get using this command, and that will give you like a very nice environment for Ubuntu 15.04 or 15.10. And then I'm just creating a little virtual environment here. So if you want to follow along, that's how you do it. So what we're going to try to do is just link Celery and your Rabbitmq into Django. And then we're going to try and use tasks, asynchronous tasks, to keep these page loads from timing out. And then associate a running job with a progress bar. And then we're going to hopefully link CPU cycles to billing, and that actually will fall out as just a trivial consequence of what we do, but we won't explicitly go into it. And this I wrote down, and it was false. Celery has an autoscaler, but what Celery's notion of autoscaling is that it is, you tell it a number of CPUs to use, and if it gets a very long queue, then it can maybe expand within the thread pool, but it can't expand across nodes. And really, if you have 8 CPU or 8 threads on your machine, you just tell Celery use all 8 of them, and if they're not busy, they just sleep. You don't care if they're in the background not doing anything. So I didn't find that Celery autoscaler was very useful, although maybe someone else here has tried it and found it useful. But so Celery is kind of a front end to Rabbitmq, which is a message broking software. And message brokers are Rabbitmq's main funders are people in the finance industry. So you give it some JSON serializable object, maybe it's a string saying buy this stock, and then its goal is to really, really fast send a message to some person who wants to sell that stock. And so they've got a very sophisticated way of doing it, and it's kind of like a job scheduler in that sense. It's saying, I'm going to take this message, I'm going to route it to a certain place, I'm going to find workers who can accomplish this task, and if I can do it, then I mark the task as successful. So the thing about Rabbitmq is it's the best, and there are a number of other things, like you can just use your SQLite database as your message broker if you want, but my view is that this is really a pain, and you don't want to learn 2 of these. You just want to learn 1 and be done with it. So you never want to be in a spot where you got all your infrastructure set up to do your job scheduling with your SQLite database, and then you have to swap it out because it's not doing what you want. So this is the most well-tested and popular stack. Okay. So Rabbitmq implements this thing called the Advanced Message Queuing Protocol, and it passes data between applications. So the specification is 300 pages long, all of it boring, but basically what it is like an email server. it sits in the middle, it listens for messages, it gets them, and then it passes it along to whoever needs it. Okay. So Celery is built on top of that as kind of a wrapper layer. Celery doesn't do anything that Rabbitmq can't do by itself, but you've got to write a bunch of boilerplate to do it. So in that sense, the boilerplate kind of becomes an obstacle a lot of the times with Celery. So you read online, a lot of people just say, just don't even use Celery at all. Just send the message directly to Rabbitmq. But you can keep it in mind as an option as doing this. So the first thing that you want to do is get your Rabbitmq server up and running. Okay. And so what we'll do here is make sure. So 5672 is the well-known port of the AMQP protocol. So if you have something listening on 5672, then you can look at it and, oh, that's Rabbitmq, and it's listening there, and I can send messages to it. Another thing is you can use this Rabbitmq CTL and look at the status of your Rabbitmq. And it will give you this variegated information, not all of it useful. But in this case, it's saying I'm Rabbitmq, I'm listening on port 5672, and I'll receive it from anywhere. Okay. Sometimes you might need to kill your Rabbitmq very violently, and then you can restart it with this command. So generally when you install Rabbitmq, it's your basic service model like Nginx. Once you install it, it starts running. So you generally don't need to type this. But if you do, it's nice to know. So I wanted to show you how to get the very... okay, I'll be very careful. So I wanted to show you how to get the very minimal Rabbitmq up and running. And the way I did this is I just found a git commit with a very minimal amount of, how do you say, the minimum number of details to just get you up and running. So if you go there, we're now at this commit. And this commit has very basic stuff. So if I look here, oops. I have this thing called send message, and this is just straight from the Rabbitmq tutorial. You use this pica, you connect to localhost, and you want to declare a queue called hello, and you say I want to send hello message to hello world to Rabbitmq. So if I do this, there we have it. We've sent a message to Rabbitmq. Okay. And so what we can do, we list our queues. We can see we've got hello there, and it's got one message in its inbox. It hasn't sent it to anybody because there's nobody to receive it. So if we receive a message, there we go. We've received it, and now it's just sitting there waiting for more stuff. Okay. And if we list the queues now, hello has 0 messages. So just to make the point more explicit, we send the message 4 times. We list our queues. We've got 4 messages in the hello inbox. Receive the message, and then we're getting it 4 times back. Okay. As this shows, periodically you're going to get these really meaningless queues that you really don't know what they came from. And so you might want to just get rid of it. So this is how you get rid of just queues that have become stale and are not doing anything for you. Okay. Then once I do this, we have no more queues. So once we've got the very basic Rabbitmq stuff up and running, we want to wrap it into Celery. So in order to do that, you go here, and the command to what we have is a bunch of tasks. Okay. So for instance, what I've done here is I've created an app. It's called Tasks, and it's going to send the message to the broker with a username guest. He's going to be at localhost, and his routing key is just a /. He's going to be routed through that queue. Okay. So here's a task. We're going to do add x plus y. Another one is just a bunch of random FFTs. Okay. So to start this worker up, let's see, app equals. Is this tasks? Alright, so when we started this up, it recognized, oh, there's this tasks.add. There's another one for doing random FFTs, and you can see it connected to port 5672. It's connected to our local host, and it's using the username of guest. Okay. Its concurrency is 1 because there's only one thread on my CPU at this time. Okay. So now, when I've killed this, I'll run it as a background task here. And it's all up and running. And I can do from tasks, import add, and task equals add dot delay to 7. So when I add this, whenever I call a function with a dot delay on it and the same arguments, what's that going to do? It's going to run it in the background. So what this says is, oh, I received this task. That's what Rabbitmq told me, and it said it succeeded very quickly, and the result is 9. Okay, and so you can query the state. Say, okay, my state is successful, and I can get the result. Result is 9. And there's a bunch of things that you can do with this task ID. So for instance, if I do t.taskid, then it gives me this string, which I can then construct another asynchronous task. So for instance, if I've got a task that's running for a very long period of time, I just store this string, and then when I want to get all the metadata about the task, I just the task constructor takes this string. So I pass this string in, and everything all the metadata about it immediately becomes alive again. So this task idea is very useful for storing in your database. One thing that's kind of annoying about Rabbitmq is that they seem to not want to have a single way of doing things. You see the status and the state. I've never seen the status and the state return different things. I think they're just synonyms for each other. I think half of these things could be in this list of callable objects here, could be deleted. But I hope that they have cleaned that up a little bit. So anyway, if you want to see something go a little bit longer, we can do this random FFTs, and then I say t equals FFT random, Let's do 100,000 of them. Oh, sorry. That did it not asynchronously. You've got to delay it to do it asynchronously. And so you can see it's received this task. It's now computing all these quantities in the background. I can do 2 plus 3 now. I can do whatever I want. And 12 seconds later, it's done. Okay. So once you start Celery, it will then create a bunch of Rabbitmq or queues. So these are always kind of surprising when you first see them. Oh, I've got this Celery queue which has nothing in it, and I've got these weird sort of task looking things that just exist now, and I don't know what they're doing. Periodically you have to just clean those all out by resetting the server. Okay. If you want to get, if you have like a nicer computer, then you can get the, you can set the concurrency. Since my virtual machine here only has one thread, then that's not very helpful. The default concurrency is nproc, whatever nproc returns. So you can have it do using 8 threads or 1 thread or whatever. Okay. Once you have gotten your Celery up and running, you might want to embed it in Django or Flask. And in order to do that, you need to write some boilerplate. And one thing is that Celery used to accept pickle. So Python pickled modules, they would just, the sort of compression that is used in Python. That turned out to be a very big security vulnerability because people could start running arbitrary code on your Celery workers. And so they decided you need to make some decisions about what sort of content type you're going to accept. And so this is a very safe route. Just say, accept the content that is just JSON. Just make it be strings or some sort of JSON serializable objects, and then Celery will accept it. And if you pass it pickled objects, which you know, the sharks floating around the internet will try and do weird things to you. They might try and send you pickled stuff into your Celery workers if you allow that to happen. So these are the things you need to do. Just add this boilerplate, add your broker URL, and then you need to define some jobs or tasks in your Django app. Okay. So this is very detailed, and the reason why I made it very detailed is because one wrong statement in here is very baffling. It's not clear. The error messages are not all that good. So if I go back to my Django example here, I've got now my manage.py migrate. Oh my god. Oops. Okay. And so the way I did this was I just tagged a bunch of commits of increasing complexity. So if you want to look at this code, you need to check out this commit. Oops. Okay. what's actually going to happen. And now we need to start up the Celery worker. And you can see that the Celery worker has figured out that we have a task that just does a bunch of random FFTs. So this is good. It looks like the Celery server is already up because we were using it just a second ago. So we might want to get rid of that. Okay, so that's ready to go. It's ready to start receiving tasks from our website. Okay. Now I can just run our server. Uh-oh. Uh-oh. Alright, you guys can wish me luck that this will actually work. Okay, here's my server. Huzzah! Okay, so this is my Django app, and it runs these FFTs, and by default it's going to compute 20,000 of them. And watch what happens when I click. So when I click compute FFTs, over here I should receive a task. So you can see, oh, I've got a post request. I hope it actually worked. If it didn't work, I might cry. Oh yeah, it received the task there. So right now this server is doing a bunch of FFTs. It's received this task. In about 20 seconds it's going to say, okay, I'm done doing this. However, what you've noticed here is that I've done this computation and it's basically doing a denial of service attack against my own web server, right? It's everything, all the compute is being done on my web server, so I really need to think of a way to make sure that that doesn't happen. And also, you have no clue when you click this button that the actual task was received. You have no confirmation there that that actually happened. So we'll go into, maybe we should look at the code a little bit more. So for instance, the settings.py, what you need to do in there to make sure that this works. So I've got my broker URL, which is now localhost. I have to define these, the sort of content types that Celery accepts. And I've installed my jobs app. That's pretty much anything that's, how do you say, it's not anything different than you normally do. And then in my jobs file, I have this task.py, which basically all this does is it just does a bunch of random, number crunching, just so we have some time to wait. Okay. And I've got this decorator in it, and this decorator here says, oh, I am a task that Celery should be allowed to run. It's something that Celery should detect, and when the Celery receives a task of that type, it should run it. Okay. So anyway, that's rather boring, but So these are the problems with this minimum example. You don't get any feedback. You don't know when the task is done. You don't know how long the job will run. So in order to improve this, you've got to start storing this task ID in this session. And that allows you to construct the Celery task later when maybe a user comes back. Okay. So if we wanted to do that, I probably shouldn't have done that as root. That might have been really bad.
It's fine, still do anything else as like any other user ever.
You know what? I'm just root the entire time now.
What's the worst?
Yeah, that's right. Now all these files are owned by root. I don't know who's doing what. Okay. Let's see what actually happened here. So I don't know that I actually changed anything. Okay, so when we get this task, if we now start to compute this thing, I think once we've hit it, it now says what's going on. It says, okay, my task is now pending because I have extracted the task state from the task object. And so if I refresh, oh, I don't want to refresh to that page because of the post request. If I refresh, it's going to be really annoying for people, but as you can see, eventually this task is going to succeed, and perhaps the FFT task will complete. Now I haven't set up any asynchronous stuff, but by default this task is moving from pending to finished. And that's kind of weird because your users always say, okay, my task has been on the queue for about 12 years now. What's going on here? So the way that you can make sure that the users can see things change from pending to started to finish is that you just put in this very simple statement. You say, I'm going to track my started tasks. So storing your task IDs in the session is probably a little bit bad of an idea, but it's very easy to do. But if you want to get something a little bit more substantial, you just store those task IDs in a database. And in order to do that, you need to have users associated with a database. So to do that, I will now, how would you say? Tasks in DB. So when I store a task in this database, I have to migrate my database. Oops. Migrate. I don't know why I'm doing this, just out of superstition, I guess. And hopefully this will work. Alright, so now we have a login page here, and my name is Fufu, and my password is some trivial thing. I log in, and now I can remember that I have various jobs here, and I can compute it. Okay, now it's in progress, and I can see my job, and it's pending, and its result is unknown. So hopefully, oh, yes, we received this task here. So I can just refresh this page a little bit. And eventually this should actually finish. And when I do that, it comes back and I look at my task and it says the task succeeded and it returned nothing, and this is the time that it actually succeeded. So if the user logs out and logs back in, actually I think I need to clear my whole browser cache maybe. I still have this job in there, and I still know what I did last time I came there.
What would happen if you reset the Rabbitmq? Like you said, get rid of
Oh, yeah. So if you cleared your Rabbitmq, that would be real bad. That would be real bad. Because Rabbitmq knows about these tasks, right? It's the database only knows about the task ID. So you clear your queues, and all of a sudden this is gonna, I don't know, it won't segfault because Python doesn't segfault very often, but it will do something weird, I guarantee it. So, all right. So I'm not sure if you're interested in this. So in order to implement a progress bar, you've got to use something called custom states. So we've seen that states in Rabbitmq go from pending to started to finished. If you want to be like 1% finished, you've got to create what's called a custom state. Because the state is just a string. It's not like a C++ enum that has only a finite number of variables for it. So, without further ado, I'll show you how to define a custom state. And that will facilitate creating a progress bar here. Actually, I should probably, yeah. Sorry, my Celery workers have now changed. So let's take a look at this. So what here, we've called this a shared task, and it's just going to do a bunch of brainless FFTs. And in order to do a progress bar, this is just a very basic way of doing a progress bar for a for loop. I'm going to put a counter there, and then if the counter is basically divides the loop into a 50th of the total loop, then I'm going to update the state and put this metadata, which tells our current part and the total part. Okay, so can anybody guess why I had to do this kind of convoluted way of making the progress bar? I had to divide it into 50 intervals. Why didn't I just use everything single step?
Because the for loop would flood.
Would what?
Excuse me, flood the response loop. It would just constantly take traffic, right?
Yeah, that's exactly right. It would. So it would send so many messages to the Rabbitmq
You may as well
broker.
just wait for this thing.
Yeah, it would basically flood it. And so, actually, one thing that's nice about that is you divide it too finely. Rabbitmq will tell you, hey, it gives you a very nice error message that says, don't do that. I don't need an update on my progress bar every 3 microseconds. That's too much. So anyway, this code does the random state, and for just so I had something to return, I returned a random number here. Okay, and since I've changed my code, I need to kill my Celery. Let's see. Those Celery workers have to die, and they've got to be booted up again in order for this to work. Okay, so Pray for me that this works. Okay. So it's kind of working, right? I have to do a page refresh to get this to work because I'm a noob. But it actually is updating the state. It's figuring out where it is in the task. And if you look at this, the worker is giving us information. Every time we update the custom state, it's going, okay, I'm at j equals 40, j equals 51, j equals 30. And I refresh, and then it goes like that. So anyway, if anybody knows how to make that update itself, I would be super glad, because I have no clue how to make that thing just...
All you would do is click JavaScript, and then you just Ajax.
Ajax it?
Two, and then you would just, all you would do is type JSON on the other side. On the other side, spinning back the current info.
Oh,
you
okay.
read that with JSON, with Ajax, and then
Okay.
you update it via JavaScript.
I'm gonna have to like pick your brain after this because this is like super annoying. I think I might get murdered by a user if I did this.
What's your refresh at? Like
I'm just refreshing it with
Oh,
my
you're doing it right
hand.
now,
Yeah,
right?
man, I'm doing it with my hand.
I thought you had it on the page.
Yeah.
Oh yeah, there's easier way to do that.
Yeah. Hey, I think this works adequately.
It was quick enough that I figured you had some kind of timer. Or
Yeah, I thought you had exactly what I thought. I thought you were running manual.
He's like, well, I wrote a WebSocket. So
Yeah, I wasn't gonna write a website. I can't spend 3 weeks on this talk. I mean, God forbid that. Yeah. All right. So. All right. Now another thing that people often do is they launch compute jobs that they regret almost immediately, and you want to make sure that they can regret them productively. And so I've got this code here that you can check out that shows you how to revoke and cancel a job. So we will see if that works. One thing that I noticed about doing these progressive git commits with increasingly complex code, when you realize you screwed up,
Right, how do you go back?
yeah, I don't know. There's a lot of screw ups in here, alright? So
We were talking about that earlier, so as soon as you started with the commits, I was like, holy shit, you did it.
yeah, I did it. I thought I would not screw up, and I screwed up big time. Okay, so I'm gonna restart my Celery workers, and I'm gonna run my server again. And let's see that this actually works. I'll refresh the page. And let's see. Alright, so now I've got a cancellation bar. I'm like, oh no, I don't like that. And I can just cancel it. And Celery has this weird thing in that it says, don't revoke the task. That's like very rude. It's a very rude way to kill the task. And then it gives no alternatives about how the task should be killed. So I just revoked the task. It's very rude. It's kill -9 basically. And in any case, anytime you do it, you're going to get this terminated by a signal exception. So, oh, it looks like somebody's trolling my website for... I don't know how that happened. Who is Site D Des? I don't know what that is. It looks like...
The last thing you see before you get pwned.
Running his route.
Yeah. Yeah, I'm running his route here. Well, what am I doing? Yeah, you know, I don't even have a domain name here. Like, they have literally just crawled to this IP address.
there's only a few million of them.
There's 4 billion of them. A few million. 4,000 million. So, okay. Some guy from France is trying to screw me over somehow while we're doing this, but, alright. So we need to move from one node to two because as I said, basically what we've been doing is just our own computation is doing a denial of service attack against ourselves. And so to move from one node to two, not that bad, but it has a few kind of tricky things, and I recommend just trying to get the very most basic stuff up first. Okay. So I'm using gcloud, and so I have both this external and internal IP address, and from what I can tell, the internal IP address has no sort of firewall in it. So even though this only accepts traffic on 80 and 443, you can still get to your Celery workers on socket 5671. And so we want to see, maybe you want to see that surface is up, but I've got here another thing that's my broker, okay? And so he is my broker, and he is running on 5671. I need to make sure that he's up and actually doing something. And hopefully that will make everybody go away from France. And so when I send this, when you're working remotely with Rabbitmq, you can't use the guest account anymore. The guest account doesn't work, and so you've got to start setting up some users. So with your broker, you do sudo Rabbitmq ctl delete user guest. Okay, my user guest is now dead, and I'm going to add my name and a password. Oh, I've already done that. Okay, and I also need to add what's called a virtual host. So this is kind of like a virtual host. It's probably most analogous to like a stock. So you're saying, all right, I want this transaction routed. I want to buy a stock. It is Micron, and so Celery will have all these various stocks that are going to be routing messages, and so each stock would have its own virtual host. That makes sense? It's kind of like your Postgres database. You have to set up a database for each project you have, even though you might have multiple, a single instance there. Okay. Let's see. And then you've got to set your permissions. Go. I'm just giving myself wide open permissions here because I don't really understand the what is it, set permissions minus P. All right. And so now I can go back to my broker here, and I want to send a message to that. And I say, okay, I'm going to send a message with my username, my password. I'm going to send it to the internal IP address, and I'm going to tell it what the virtual host is, which is test. And I'm going to do the same thing in the receiving of the message. I just set up my username, my password, my port, and the receiver will be on the broker. Okay. So let's see if this works. Okay, so I actually don't know that the host is on that IP address. Let's check the IP address here. It is. Okay. So I'm going to send a message, and we send it to Rabbitmq, and now we can receive that message, and we got it. Okay, so that's how you move from one node to two. So we can see, but as you can see, everything is being sent unencrypted. All my username and password, right? I sent my username and my password unencrypted to my broker, which is, it's in G-Cloud, right? Can anybody do weird things in G-Cloud?
That person from France.
Maybe that person from France knows how to listen to my traffic going within G-Cloud. So,
Person from France already has.
yeah, so we can still send the messages around. It's not gonna make anybody tear up that we've sent unencrypted username and passwords within our little universe there. Although if you get hacked, if your password is change me, you're probably gonna get fired, I think. So, yeah, I don't know. Maybe I'm paranoid, but okay. So I kind of always try and do this progression of complexity here from just using these sort of passing these basic messages around in Pica and then in Celery and then in Django. So to do that, Celery is very, it's exactly as you would expect in the sense that we look at these tasks and what do we need to do here? Well, guest isn't going to work anymore because I'm not a guest. Guest doesn't work on two nodes. So we put in the protocol, the back end, and Thompson, change me. It's not localhost, it is, the node is called broker. I think that sometimes works. Maybe I'll just do the safe thing. 10.240.0.3. And your port is 5672. And your virtual host is not the slash anymore, it's test. Okay. And you don't, how would you say? That was the wrong place to do it, I believe. Alright, so I want to start my Celery worker on my remote server. Oops. Tasks. Okay. And he's hanging out and he's connected to the AMQP server. And then here it's fairly simple, right? I can cat the tasks. On my other guy, I just do Python 3 from tasks import. Alright, so nothing happens over there, but over here we receive the task and it succeeded. Okay. So it's not that bad to configure it for 2 nodes. In fact, it's probably a little bit too easy to configure it for 2 nodes because all somebody has to do to start connecting to your server is know your IP address and your nthompson at change.me password, and then all of a sudden they can just connect and start receiving your messages, right? If you were a stock trading company, you definitely not want this to happen, right? It's so easy to. The Celery broker is kind of promiscuous in the first approximation. It will just accept anybody that claims to be a worker will just get work. So we need to think about that. But as we said, it's not bad. It succeeded. You can do it, longer, and I get another one. It succeeds. Longer again. We receives it over here. We get it done. It's successful. Okay. Again, as I said, setting up the worker is very simple. You can have your front end and your broker and your Celery workers over here. So I've set up this third compute node, which is called worker 1. Which can just very easily come in. It's very easy for us to go in and just join the team. This worker over here, he's saying, I want to be part of the team that computes random Fourier transforms. So let's see if he connects. There he goes. So now I've got this worker here. And my broker, he says, okay, I've got a Celery worker here. And what happens when we just start really hammering this server? I'm sending bunches of messages to it. Well, this guy received some tasks, and this guy also received some tasks. So it's not that bad. All you've got to do to get the Celery workers to connect to the broker is just say, hey, I want to be part of your team. Okay. And it also distributes these tasks pretty fairly. So it looks like this guy received 5, and this guy also received 5. So if you're worried about load balancing, it seems to know fairly well what the load on each server is. Make sense? All right. Oh yeah, and then it tells you when you create this cluster of arbitrary size. It says, okay, I'm syncing with another node, and then I sync, and then they both know about each other and can go about their merry way. Okay. Again, running Celery with Django on a second node is very easy as well. So if I wanted to go, oh, it's probably not what I wanted to do. My broker here, basically all I have to do to get this guy to connect to another server is very simple. 5672. Password change me. Okay. I just say Django. All right, so it's now connected to there. So that's basically all you have to do to get it from, once you get your basic Celery working up, then it's just one line of code to get it to work on a different node. Okay. So if you want to encrypt the traffic between your producers and consumers, you have to set up a certificate authority. So I think Darko has probably set up a certificate authority for your Docker workers, right? This is a big thing, is setting up certificate authorities.
I didn't.
You didn't? Okay. Has anybody ever set up a certificate authority before? Glenn set up a certificate authority. It is a pain in the ass.
Didn't want to.
Yeah, so your certificate, your web server has to authenticate who it is. It says, I am this dude, and you can check my certificate authority. Optionally, you can also give a certificate to your browser, right? So you can say, I am a browser that is allowed to connect to this server. So you authenticate both the website server and the user. So that's what a lot of big corporations do, is they give you a root certificate that says, oh, this computer can connect to our internal network. Okay. With Celery, it's the same. What you do is you say, I'm going to create my own certificate authority, and the broker will own the root certificate. Then the broker will sign cryptographically certificates for the Celery workers. And when you do that, then the Celery workers come in and say, I want to join your team, I want to work for you. You can say, did I tell you that you could? And if so, then you're allowed to. Otherwise, you reject the connection. Okay? So I have put up a bunch of directions for how to do that. And if you're interested, you can go through it. But I think we're getting to the point of diminishing returns in going through this. Just a few quick things. Your encrypted communications over Rabbitmq are served on a different port. It's generally 5671, though you can change it. And how do you say? Yeah, there's just a lot of things that can go wrong when you set up your own certificate authority. So having these sorts of, looking at your Rabbitmq broker log, and you often, once you set up your certificate authority, you've got to immediately just clear out your entire Rabbitmq broker, because its old stuff is contaminated at that point. It doesn't know how to think about the old stuff and the new stuff, and what sort of things it's supposed to authenticate and what things it's not supposed to. So you just got to start from scratch. So if you have a running system that doesn't use encryption between Celery workers and producers, it gets really ugly to make it encrypted. And so with that, I will accept questions if you have any. Yeah.
So if I have, my main server is accepting and sending messages, so like you click the button and it says you want to start this task, and it has the task defined.
Yeah.
It sends it to the broker, and then I have my worker. My worker needs to have the same exact task defined as my original server that sent that message.
Yeah.
So, because if they have different names, it won't work, and if they have the same name but different code, it's going to produce odd results. Is that right?
Yeah, definitely. So the question was, if I have a web server and a compute node that have different tasks defined, will things go horribly wrong? And the answer is yes, they definitely will. This becomes a pretty good case for using Docker images, because it allows you to keep your environments synced up a lot more efficiently than just trying to go through and ad hoc change all your servers. I have 3 here that I use for this talk, which is not that many, and it's still a real big pain to go through and change all the code on each one to make sure that they all are thinking about the same tasks and are doing the same thing.
And the broker server itself, does it need to know about the tasks at all?
Broker doesn't need to know about the tasks. The broker, he takes the JSON serialized message and then he passes it along with some metadata. And then the Celery worker knows about the task. He says, oh, what is the task name? That's something I got JSON serialized from the broker. The task name is FFT random. And therefore, I'm going to call that which I know about. So, anything else? Oh man. Okay. Well, I think we're done then.
All right.